Hello, so this is the Unit 3, Lesson 1. It's a special angles and the trigonometric functions. So there are special angles that you need to remember. The reason why these are called the special angles is because these are the angles that have the exact value when they are applied to the trigonometric functions. So for example, sine, cosine, and tangent, if you use these angles, then you actually get the exact values. So let's actually examine how we get them. So first thing is the 45 degrees angle. So how we do is that we create a equilateral, not equilateral, sorry, the isosceles triangle that has 45 degrees angles as the base ones. So in this case, we have a square, and then what we do is we basically draw a diagonal line. Now, since this is a square and I draw the diagonal line, the angle up there and then down here actually becomes 45 degrees. And as you know, each side length is 1. That's how I set it. And using the Pythagorean theorem, what happens is that we need to find this diagonal line's length. So what happens is then 1 squared plus 1 squared equals, I'm going to call this one h squared, but that basically is 1 plus 1, and that's 2. So h then is square root of 2. Now, some of you may ask me, but why don't you put plus minus in the front since you're taking a square root of it? Yes, you're supposed to, but in this case, we're talking about the length of a line. The length of a line does not have negative length unless you're talking about something else. So that's why we do not have the plus minus in the front. It's only plus. So then this h becomes square root of 2. Now, using this, what we can create is a chart for sine, cosine, and tangent. So the first thing is a sine 45 degrees. So hopefully you remember from your primary trigonometric ratios. So sine is the opposite over hypotenuse. So I'm going to use this angle as our angle. So then the opposite is 1, and the hypotenuse is obviously the h. So this becomes then 1 over square root of 2. And you can say this, but also this could be 2, sorry, square root of 2 over 2. Now, hopefully you understand this. This is a part of the rationalization, so I'm not going to explain this. Now, if you then look at cosine 45 degrees, and cosine 45 is the adjacent over hypotenuse. It's the ka. So adjacent is this one, and then the hypotenuse is that. So it's again 1 over square root of 2, which is also square root of 2 over 2. And then lastly, it is a tangent 45. Now, tangent is TOA, so it is opposite over adjacent, so it's 1 over 1, which is 1. So we have those. And then what about the other ones? So we have two more special angles, which are 30 and a 60. So here we have the equilateral triangle that each length is all 1. Okay. But in order for me to make the calculation easier, what I'm going to do is I'm going to actually double both all the lengths. So the triangle is now twice as big, but the ratio does not change. Okay, the ratio does not change because we made every line or every line twice as big as before throughout. So what I'm going to do is I'm just going to create these as 2, 2, and then 2. Then what I'm going to do is I'm going to divide this in half. And then obviously we know that it is 1 and 1. Now hopefully you see why I used the 2 here. If I used 1 as the each side length, then you will deal with 0.5 over here. However, we do not want that because decimal is kind of like tedious for us. So what we're going to do then is this. Since this is a equilateral triangle, we know that this is 60 degrees. We know that this was also 60. However, we divided in half, so we know that it is a 30 degrees. So we have a triangle. Hopefully you can see it. Hopefully you can see that it's this triangle that we're going to use. Okay, only the half of it. So it is a right angle triangle where the 60 degrees at the bottom and the 30 degrees at the top. And we're going to do the same thing. So what is my sine? Let's start with a 60 degrees. So the sine 60 again is, so it is opposite over adjacent. Now, then the question is, what is my opposite? So we actually have to then go through the same process as before, which is a Pythagorean theorem. So then it is, I'm going to call this one as b, sure. So it is 1 squared plus b squared equals 2 squared, which is 1 plus b squared equals 4. Then the b squared is obviously 3, so b then is a square root of 3. So this is a square root of 3. Now, having said that, the sign is opposite square root of 3 over the hypotenuse, which is 2. What about cosine cosine 60 degrees? Now, cosine 60 degrees is then the adjacent over hypotenuse, which in this case is 1 over 2. And then tangent 60 degrees is opposite over hypotenuse, or opposite over adjacent. So it will be square root of 3 over 1. Then what about the sine 30 degrees? We still have the 30 degrees in our triangle, so the same thing. Now, this case, I'm gonna create another triangle, or I'm just gonna draw the triangle slightly differently so that it's easier for you to see it. What I'm gonna do is I'm gonna draw this yellow highlighted triangle, and I'm gonna rotate that to the sideways so that we have this 30 degrees at the bottom and the 60 degrees at the top. Okay, I just rotated it. So we still have the hypotenuse of 2. However, the square root of 3 is at the bottom now, and then 1 is at the side or the top, since we rotated it. Now, then sine 30 degrees is opposite over hypotenuse, which is 1 over 2. And then cosine 30 degrees is then adjacent over hypotenuse, which is the square root of 3 over 2. And then tangent 30 degrees is opposite over adjacent, which is 1 over square root of 3. So these are the special angles and the trigonometric ratios associated with these special angles. So there are 9 of them. So yes, you have to memorize these. However, the easiest possible way, there are 2 ways. I'm not going to show you the first way unless you're interested. But the second way is basically drawing 2 different triangles. One is the triangle with 30, 60 degrees, and another one is drawing a 45 degrees angle triangle with the side length of square root of 2, 1, and 1. And then you simply can derive from your trigonometric ratios from these 2 triangles. So having said that, we know sine 45 degrees is 1 over square root of 2, or we can say it is a square root of 2 over 2. Either is fine. Tangent 60, we already know that, which is square root of 3 over 1, or you can simply just say square root of 3. Cosine 30 degrees, we already found that as well, so it is square root of 3 over 2. Then the rest actually becomes simpler because as long as you remember these, it's just a mere calculation. So we're here we have sine 45 times cosine 45. Oh my god, there are like so many letters and so many numbers, but it really doesn't matter because these are just the ratios. So sine 45 is square root of 2 over 2. And then cosine 45 is also square root of 2 over 2. Sine 30 is 1 over 2. And sine 60 is the square root of 3 over 2. Then rest is just a multiplication of the radicals. So hopefully remember this. Hopefully you remember this. So in this case, we're multiplying fractions. So it should be the denominator by denominator and the numerator by numerator. So this is going to be the square root of 2 times the square root of 2. That gives me square root of 4 over 4. And then square root of 3 over 4, right? There is 1 times the square root of 3, which is the square root of 3. Then we just need to simplify this further. That square root of 4 is 2 over 4. And then square root of 3 is, square root of 3 over 4. Then finally, it will be 1 over 2 plus square root of 3 over 4. Okay, so that was quite simple. Let's actually then get to the next slide. Now, then if you look at the next slide, it's pretty much the same. It's pretty much the same. So all you have to do is, I'm just showing you a bit of it. Now, a bit of the proof. So in this case, all you have to do is just find what the value of this side and find what the value of this side, since we have the exact angles given to us. In the later proof, if you do not have the actual angle, then please do not assume the angle is whatever the angle that you think you want to use or you like to use. In this case, it's just a specific case where we have 30 degrees. So here, this is kind of weird look, isn't it? It says sine 2 and then 30 degrees. This actually means it is sine 30 degrees square. So for the sine, cosine, tangent, their square actually comes down right before your angle. The reason is this: if you put sine 30 degrees square without any brackets, this actually means it is a sine 900 degrees, which means that it just is sine 30 degrees square. Okay, so when you want to put sine square 30 degrees or sine 30 degrees, the whole thing square, we have to put sine square 30 degrees. This is a mathematical notation. Okay. So having said that, we know sine 30 degrees from the triangles. The triangle for the 30 degrees, we have 30 degrees and then 60 degrees. We know that this was square root, this was, whoops, 2. We know that this was 1. This was square root of 3. So sine 30 degrees is then 1 over 2. So the top will be 1 over 2 squared over. Now the cosine 30 degrees is then square root of 3 over 2. Now let's see whether what this becomes. So this actually becomes 1 over 4. Oh, by the way, this is left side. Over 1 minus, sorry, not 1. 2 over 2 minus the square root of 3 over 2, which gives me 1 over 4 over 2 minus the square root of 3 over 2. Now, if you take a look at this, this basically means it's 1 over 4 divided by 2 minus the square root of 3 over 2. And that also means 1 over 4 times 2 over 2 minus the square root of 3. Now, hopefully remember that we can cross and we can cancel, or we can simplify in a crossing way. So this then becomes 1 over 2 times 2 minus square root of 3, which is then 1 over 4 minus 2 square root of 3. Now, then we have to look at whether our right side is the correct version. So then our right side is 1 plus cosine 30 degrees. Now, cosine 30 degrees, we know that it is square root of 3 over 2. Now, this then gives me 2 plus square root of 3 over 2. Well, if you cannot follow it, it is 2 over 2 plus square root of 3 over 2, which is then 2 plus square root of 3 over 2. Now that here I really can't tell whether the left side is equal to the right side, so what I'm going to do as an extra step is that I am going to rationalize the left side by multiplying the conjugate. So hopefully everybody remembers conjugate. So then it is 1 over 4 minus 2 square root of 3 times 4 plus 2 square root of 3 over 4 plus 2 square root of 3. So this becomes 4 plus 2 square root of 3 over 16 minus 12. Now this then becomes 4 plus 2 square root of 3 over 4. Now if you hopefully look at it, I can actually divide everything by 2. So then this becomes 2 plus square root of 3 over 2. So in the end, the left side is the same as the right side. So be really careful. It's not that you just forget whatever you learned in the rationalization as well as the radicals, okay? Because that will actually come in as a tool that you have to use to get to the answer, okay? So this is part 1, and I'm going to record the part 2. Okay, bye guys. Oh, by the way, please watch the part 2. Okay, you really do need to watch the part 2.